everyone, and welcome back to my video tutorial. My name is Dylan Lequien. It is advisable that you have watched the videos on oblique and isometric before watching this one. Today, we will discuss about orthographic projection. You will learn how to position the different views and also about the dimensioning rules and regulation. To start, let us define orthographic projection. It is a means of representing three-dimensional object into two dimensions. Generally, for orthographic exercises, you will obtain a 3D object. Usually, it will be in isometric projection, and you will be told to draw the orthographic views. If you remember in grade 8, orthographic views consist of front view, side view, and top view. Let us take a simple example. So here is an L-shaped block in isometric projection, and also there will be different arrows which show the front view, side view, and top view. We will now draw the view. We start with the front view first, and then the top view. Note that for grade 9, the top view will be always below the front view. I repeat, the top view will be always below the front view. The problem now consists about the position of the side view, whether to draw it to the right or to the left of the front view. In fact, we have to draw the view on the opposite to the view's direction. For example, the top view arrow is at the top, but we draw it at the bottom. And the arrow of the front is at the left, but we draw it to the right. Obviously, the side view will be positioned on the left as its arrow is on the right. So what you have to remember is that you have to draw the view on the opposite side of its arrow. Generally, the top view arrow will be always from the top, but the front view or the side view can be to the left or to the right hand side, depending on the question you are given. So you must check this arrow well. In fact, in this example, the front is on the left and the side view is to the right. Now, let us take another example where the front and side view position will interchange. At the end, we will make a comparison. So this is the isometric shape block. As you see, the front view arrow is now to the right and the side view arrow is to the left. Firstly, we draw the front view. Of course, the top view will be appear at the bottom of the front. Now, concerning the position of the side view, it will appear on the right as its arrow is on the left. There is a difference between the positioning of the orthographic views of the two isometric blocks, as the front view and side view direction is different. So, you must be very careful before starting drawing orthographic views. And by the way, it is advisable to draw a sketch before starting drawing the orthographic views using instrument. Now, there is one other thing that you may have learned in grade 8. It's the major line. It is a line inclined at 45 degrees. For case 1, the major line will be placed here, and for case 2, the major line will be drawn here. As you observe, the major line is also different in both cases. In fact, the major line is a sort of connection between the side and the top view. We will see the importance of the major line in a few minutes. Before starting drawing, we must know different line types. So the different types of lines, we use it in technical drawing. They're very important for designers, industrial engineers, architects, and other technical people. So the thickest line is the outlines. We use them for visible outlines or edges. Next we have construction lines. It is thin and we use it for construction purposes or crates. Also we have the center lines representing center line of circles, semicircles or arcs. And finally we have the hidden lines. It is used to represent hidden details. So of course you have the different tone and pencil grades for these types of lines. For outlines you can use HB, B, or sometimes or even 2B, 2H for the construction lines, H for the center lines and the hidden lines. Now sometimes you have only like one pencil to draw, so you must apply different pressure on the pencil to have the different tone. You will see in some of my video I will use only one pencil, but I apply different pressure to my pencil just to have different tones. So now I will show you the different steps to follow when drawing orthographic views. You will get the isometric drawing. What you can do first, draw a crate for the isometric block. Now, draw the crate for all the three views. You will have to measure the maximum height, maximum depth, and maximum width of the isometric block. So, as the direction of the front is to the left, we draw it on the right. the direction of the side is on the right, we draw it on the left, and like I just mentioned previously, the top view will be always below the front view for grade 9 level. Now, let's draw the front view. You have to measure the dimensions needed, that is the circular diameter, etc. So when drawing the projection lines, you have to draw it in such a way that it reaches the side view and the top view. Then you draw the outline forming the front view. So why the projection line is drawn till it reaches the side view and the top view? Because to avoid taking measurement twice. For example, the circle diameter will be also appeared as hidden details in the side view and top view, and thus it saves time. Now we move to the side view. So as you see, I have to take only the measurement of the thickness of the upper part of the L shape, as the rest of the outline will be placed on the projection lines. Now I elongate the projection lines from the side view to the top view by passing it through the miter line. So that's how I use the miter line. It is like a connection in between the top view and the side view. Last step, I draw the top view. So as you can see, there's nothing to measure here. I have just to draw the outlines by using the projection lines. It's completed now. You can see I used different colors so that you can clearly differentiate between outlines, center line, projection lines, and miter lines. Let's see another example where we will see inclined shape and a hole in the form of a square. So like I have just done for the previous isometric block, I draw the three grades first for the front, top, and side view. So now I draw the construction lines which will help me to draw the front view. Every construction lines will be projected on the side view and the top view. This is why we call it projection lines. Now I draw the front view using outlines. Afterwards, the side view is drawn. The other projection line that I use to draw the side view will be done in such a way that it reaches the top view by passing through the miter line. And last step, the top view is drawn. Finally, you got your drawing. Don't forget that you must do everything with your pencil. Here I use different colors to make a difference between the types of lines. It's page 128, exercise 5. So before starting using the instrument, we'll do a sketch of the orthographic views. This is the front view. At the bottom, we have the top view. And on the left hand side, we have the side view. Now we take the maximum measurement. The front will be 40 mm height, 90 mm length. The side view will be of a length of 70 mm. This dimension will be repeated to the top view. This one will be repeated here. The instrument that you need, you can use set square of 45 degrees, 60 degrees, T-square, your pencils of different grades, your compass, so we start with the left part, that is the side view. You could have started, of course, with the front view. I'm using fade lines for the crate. This is the grade for the side view. I check again the height, 40 mm. The distance in between the views, we can take it as 40 mm, as mentioned in the MIE technology textbook. Now I'm drawing the crate for the front view. I have elongated the projection lines downwards. Why? Because I already know that the top view will be placed at the bottom of the front view. So this is the mitre line. As I use my set square of 45 degrees, as the mitre line is inclined at a 45-degree angle. Here is the grade for the top view. So here it is the grade for the top and the front view. Now I start drawing the front view. every horizontal projection lines will be drawn in such a way that it reaches the side view. And the vertical projection lines will obviously reach the top view. You must be very careful when taking measurement. Now I use outlines to draw the front view. For the circle, don't forget to draw the center line first. Part of the center line also will reach the top view and side view. I use the circle template to draw the circle. You could have used also your pair of compasses, but with the circle template it's much more easier. Now I move to the side view. The projection lines will be elongated till it reaches the middle line and it will go through the top view. So this is why the middle line is important. It's a kind of connection in between the top view and the side view. I'm using dotted lines now to represent the hidden details. Don't forget the circular hole will be drawn using hidden details in the side view. I think it's done. Now we move to the view. As you may notice, there's nothing to measure here. You have to just follow the projection lines. So this is the advantage of using projection lines. I think there's a hidden detail that I miss in the front view. So here it is. The circular hole will be appear as hidden detail in the top view also. I think we have completed, but we must check again whether all side is visible and all hidden details also have been drawn. Yes, it's completed. This is another important part of orthographic drawing: dimensioning. Here we will learn how to add dimension to orthographic views by respecting different rules and regulations. Here is the orthographic views. As you see, it consists of circles, arcs, square, and rounded corners. Before starting, let's see the different symbols often used in technical drawing. You have symbol for radius, diameter, square, and centerline. First of all, we will add a dimension on the top of the front view. So as you see, the arrow must not touch the front view. In fact, there is another line which shows you clearly where the arrow starts and ends. The distance in between the arrow and the view is 10 millimeter. And the little gap here is 2 millimeter. The arrow size is about 4 millimeter by 2 millimeter. For any vertical measurement, it will be done in such a way that the numbers are to be read from the right. Here also, there is a vertical measurement, and the number 30 will be read from the right. Concerning the diameter of the circle, we draw an arrow touching the inside of the circle, and the arrow is inclined at 45 degrees. For the square appeared in the top view, you just have to label only one side, but the symbol of a tiny square must be included beside the number. And finally, for the tiny arc, it is quite the same for the diameter of the circle, except that here the arrow will touch the outside of the arc, and the symbol used here is radius. One other thing, you must leave a distance of 1 millimeter to 2 millimeter between the arrow and its number must be at the center of the arrow. Now you can see how we place the different kinds of dimension to orthographic views. It's good to know the dimensioning rules and regulation because this is the proper and professional way to communicate your drawing along with its dimension. To the photographic exercise. As I have explained, the distance between the arrow and the view will be 10 millimeter. And don't forget the lines which shows where the arrow starts and ends. There's also a gap of 2 millimeter in between these lines and the view. Don't forget that the number must be placed at the center of the arrow, and the distance in between the number and the arrow is about 1 millimeter to 2 millimeter. you may notice that we don't write the unit millimeter, we just write the number. So here is the diameter of the circle, a line inclined at 45 degrees. Here you can see the dimensioning for this exercise. I could have added much more dimensions. Points to remember: it's the vertical dimension. You must write the number as if you're reading from the right. And also, the distance between the number and the arrow is 1 millimeter. It's clear how professional designers use photographic projection. For example, this one is an orthographic views for a house. This is a sketch of orthographic views for a bicycle. Here we have orthographic views for a motorcycle done by an industrial designer. That one, orthographic views for cars and even for aeroplanes. We have now come to the end of this video tutorial. I hope that you have understand all factors related to orthographic projection and also the dimensioning rules and regulation. If you have some question, some proposal, or even some advice, you are the most welcome. You can just comment below. I thank you all for your attention.